Hello everyone, welcome back to Mana CS Classroom. In the previous video, we understood what a code generator is and where it fits in the compiler. Today, we will learn two important concepts. First, the requirements of a code generator. Second, the issues in the design of a code generator. Let me tell you an example. Suppose our college wants to recruit a lecturer. What qualities do we expect? Good subject knowledge, good communication, efficient work, and completing responsibilities on time. Similarly, a code generator is also expected to satisfy certain requirements. Only then can it generate good machine code. So, requirements of a code generator. Requirements of a code generator. See, correctness, quality generated code, efficient utilization of resources, and compilation speed. These are the four major requirements of a code generator. Let us understand each one. First comes to correctness. See, if the source program says add two numbers, the generated machine code must also perform the same addition, right? So, generated code must preserve the meaning of the source program. Compiler should never change the meaning of the program. This property is called correctness. Next one, quality of the generated code. Two routes are there to college, long route and short route. If there are two routes to reach your college, what do we choose normally? We choose the shorter and faster route, right? Similarly, the code generator should produce efficient machine code. Less instructions, less number of instructions, faster execution, and efficient utilization of the resources and efficient machine code. Okay. So the next comes efficient resource utilization. What does it mean? What are the resources? So the resources that we are talking about are registers, memory, and CPU. So use them carefully. CPU registers are limited resources. Memory access is very expensive. A good code generator should use these resources carefully and efficiently. And the next one, compilation speed. Code generation should be very fast. So if there are any unnecessary delays, we must avoid those unnecessary delays. Imagine clicking compile and waiting for 1 hour. Nobody likes that, right? Compiler should generate code quickly while maintaining reasonable quality. Okay. So next, all the requirements tell us what is a good code generator and what it should achieve. But how can it achieve them? So this leads to issues in the design of a code generator. Okay. Now we know the expectations. Next comes the practical challenge. How does the compiler actually generate efficient code? So this is where design issues come to the picture. So issues in the design. So what are the major issues? Input to the code generator, target program, memory management, instruction selection, register allocation, and evaluation order. Okay. So issues input to the code generator, target program, memory management, instruction selection, and register allocation followed by evaluation order. So first one, input to the code generator. Before generating machine code, the compiler requires some information. So usually it receives intermediate code and symbol table information. Okay. So these become the inputs to the code generator. Next, target program. So the compiler must decide what type of output it wants to generate. Should it generate machine code directly or assembly code? The decision affects the design of the code generator. Next one is memory management. So imagine arranging books in a bookshelf. Frequently used books are placed nearby. Similarly, frequently used variables should be managed efficiently in memory. The next one is instruction selection. So we must choose efficient machine instructions. So code generator must choose efficient machine instructions. So if there is an instruction add a comma 1, so instead of performing this add a comma 1 cleverly, wisely, it can replace this instruction with the increment a. So compiler should select the best machine instructions which are available. A poor choice increases the execution time. The next one is register allocation. Which variable should occupy which register? Registers are like VIP seats in the theater. Only a few are available. The compiler must decide which variables deserve those valuable seats. Okay, so it has to decide which variables should be accompanied in the registers. So the next design issue of a code generator is evaluation order. The compiler must decide the order in which expressions are evaluated. So for example, A plus B star C order very matters. So a good evaluation order reduces memory accesses and improve performance. So let us summarize. Today we have learned requirements and issues in the design of a code generator. The requirements are correctness, quality, resource utilization and compilation speed. And issues in the code generator are input to the code generator and target program, memory management, instruction selection, register allocation and evaluation order. In the next video, we will learn about the basic blocks and flow graphs which are very important for code optimization. Thank you for watching Mana CS Classroom.